Hello everyone, welcome to the Knowledge Bites. I'm Deepika Singh, e-learning specialist and subject matter expert. In this video, I'm going to give you a brief about quantum computing. So let's explore it. These days, there's a lot of buzz is going on quantum computing. It is one of the most advanced computing field in computer technology right now. It is still in evolution field. Before going to the main, you can understand what before giving more on this thing. Let's first understand what is a quantum computing. Quantum computing is a multidisciplinary field comprising the aspects of computer science, physics, and mathematics that utilizes quantum mechanics to solve complex problems faster than our classical computers. I'm going to also discuss the comparison between classical computings and quantum computing in my next part of this video. So in this part, it includes a lot of hardware research and application development. Actually, quantum computing is using the aspects of the quantum mechanics to perform the calculations more faster than classical computers. Actually, it is using quantum computing. Quantum mechanics is one of the very important part of physics, and it has helped in developing many advanced technologies in physics. And now, by using these technologies, by using the concepts of quantum mechanics, this quantum computing has been evolved, and it has a unique properties of quantum physics such as superpositions, entanglement, and quantum inference to solve the complex problems. And that is something which is making this quantum computing very unique. It is using these concepts here. Instead of bits, each and every information is being considered in the form of qubit, in the form of, like, here in a simple computing we use bits either in form of 0 or 1, but in quantum computing it is been kept in the form of qubit. So we are going to discuss about these things in next part. So before going further, let's understand the applications of quantum computing. Why it is being emphasized so much. With the help of quantum computing, a lot of more development in artificial intelligence can be made. And moreover, the research is going on. The more better cybersecurity systems can be developed, more better quantum cryptography can be developed, better weather forecasting will be available, better financial modeling, so that we can provide more secure banking transactions. More better secure financial modeling things can be enabled with the help of these quantum computing, with the help of quantum computers. And we can able to develop it. The most important thing is that with the help of quantum computing, more better drug design, more better medical facilities, more better medical equipments can be developed with the help, so that they can able to provide better medical facilities to the patients. So this is the one thing. These were some of the most. Now let's see the comparison of classical computing and quantum computing. So why then, by this comparison, you are going to understand why there is so much research is going in quantum computing. Why there's so much difference? Why so much? Now the first point is data storage. If you can see through this table, you can see in quantum computing computers use quantum bits. What I was discussing before this thing, it uses qubits to store the information. But in classical computing, you can see that they use digital bits, 0 and 1. So actually, qubit is more informative. It can store the data in a more better way with the help of qubits, because it provides more faster facility processing. Qubits can exist in multiple states at once. And but what happens in classical computing, what the computers which we're using right now, they can all the information can be either in the form of 0 1, but in quantum computing it can exist in multiple states at once. So that is why the quantum computers are going to be very fast. They are still evolving states. They are developed. They are like IBM has also developed the quantum computers, but still they are not more available, and still a lot of research is going on. but in now power. Quantum computers power increases exponentially with each qubit added. Actually, like what happens in classical computers have their own, they have their one static type of speed, which does not scale up easily. But in quantum computers, as the computers will work on, as the processing is going to be done more, the speed of the computers will be increased more at each and every qubit is been added. It means the speed of the work will be, you can understand, you can imagine yourself on that what will be the speed of quantum computers, what is going to be the speed of the quantum computers. Then operations. Quantum computing operations rely on linear algebra but right now the classical computers rely on Boolean algebra. Boolean algebra, you can understand that Boolean algebra, we can use the gates, and all the gates are being made on Boolean algebra. But quantum computing uses linear algebra, so you can understand linear algebra is basically it provides more information, more results in a more easier way, in more easier timing. So that is why the quantum computing is using this. They will use algebra and equations and all these things. Then programs. Quantum programs are probabilistic, meaning each possible output has a probability. But classical computing has follows the traditional pattern. But probabilistic means like here what we used to do in programming right now in our traditional programming. If the input is something, if input is correct, then there will be an output. Then when according to the precondition, if the program is getting the input, then it will give the output. Otherwise, the output will not come. But this thing is not going to happen in quantum computing. If some input is given, it is going to use some machine learning, something, it will combine some machine learning and some own understanding, that own understanding, and with the help of their own understanding, it will provide some kind of output in the form of some probability. It will just at least some kind of information, some kind of results will come out. So this is the basic thing, which is most unique thing which we are going to get with the help of quantum computing. Now let us see some other differences, of some other comparison of classical computing and quantum computing. The first very important, the distinguished feature of quantum computing is reversibility, which is not available in classical computing. Actually, what happens in quantum computing is that here the circuits in quantum computing, the circuits must be the principle is basically that their circuits must be reversible, meaning the input state of an operation can be recovered from its output. So this is something which is going to provide more flexibility and more better speed with the help of quantum computing. Then temperature. Quantum computers can't operate at room temperature and need to be kept at extremely cold to minimize the noise. This is something a very disadvantage, some of the loophole in quantum computers. So that's why these quantum computers are still in evolving stage. A lot of research is going on in this aspect. But as we know that in the classical computers can be operated at room temperature, but still quantum computers can't be operated in this in the room temperature. Then data restrictions. Quantum computers have data restrictions because it is impossible to create a copy of unknown quantum state. This is something which is a research area which is right now going on. So these are the comparisons between classical computing and quantum computing. Now let's see the principles of quantum computing. The principles of quantum computing are built upon the idea of quantum mechanics. It's leading to a new paradigm of computation fundamental different from the classical computing. You will see when you are going to see the principles of quantum computing, you can understand your own self. There is a big difference between classical computing and quantum computing. So let's see it. The first principle is quantum superposition. So what is the quantum superposition? Let us explain. Superposition allows a quantum bit, means qubit, to exist in multiple states. With the help of quantum superposition, this quantum bit can exist in multiple states. Unlike a classical bit in which it can either be 0 or 1, a qubit can be in a state that is a combine of 0 and 1, represented mathematically. I can see, so it's an amplitude. It can mathematically, if you can see it takes the uses of alpha. It uses a probability amplitude of qubit states. So what, with the help of this feature, it enables the quantum computers to perform many calculations simultaneously, leveraging the parallelism of quantum states. Parallelism means by using this amplitudes of qubit states, it provides, when all the computing is done parallelly, it means a lot of work can be done at a single instant of time. So even though right now there are supercomputers, there are many computers whose speeds is very faster, but with the help of this concept, uh, the speed will be, you can imagine, it will be a very fast speed in comparison to these GS computers. Now, the next principle is quantum entanglement. So entanglement is a phenomena where multiple qubits become linked, such that the states of one qubit is related to the state of another, regardless of the distance. So once entanglement, the measurement of one qubit state will instantly determine the state of its partner. Actually, what happens, like, if one qubit uh, is been working on, then it will automatically link to the another state, another similar state. And so that, like now these days, from coming from one state to another state, it takes little bit time. But in quantum, with the help of this principle, automatically it will come from one state to another state. It will automatically determine itself, and that is why the speed of the system of these computers will be are going to be very far better than classical computers. So it enables the quantum computers to encode information across multiple qubits more efficiently, and it is central to the power of certain quantum algorithms. Quantum algorithms, it means in the quantum physics, there are certain kind of algorithms are being used while developing quantum computing. Obviously, algorithms have been developed. So it is going to, these with the help of this algorithm, from one state to the next state, it will automatically going to be linked. It will not take that much of time. Now, the next principle is quantum interference. Quantum interference acts the probabilities of measurement outcomes and is used in quantum algorithms to amplify the probability of correct answers while excelling in incorrect ones. It is going to, like, in quantum interferences, basically it is going to use the concept of probability. Probability, you can understand, like, if these are the possible inputs, so if these are the inputs, then there are the possible outcomes. Basic concept of probability which is there. So with the help here in quantum computing, it is going to use the concept of probability. So by cancelling the incorrect ones. So what I'm telling about this, in quantum interference, it is when you do probability, then there are questions you have learned about, like what is the possibility of correct output, what is the possibility of incorrect output. With the help of this concept, with the help of this principle, it will cancel the incorrect possibilities. So only the correct possibilities are going to come out. So that will provide more better efficiency for it. So great solutions enabling the algorithms like Grover's and Shor's to work efficiently. I'm just telling about, these are some of the algorithms which are being used in developing the quantum computers, that is Grover's and Shor's. So this will provide more better efficiency to the quantum computers. Now the next is quantum measurement and the collapse of the wave function. If I'm talking again, If I'm talking about quantum computing, then obviously physics concepts are going to be used, are being used. So what happens in the when a qubit is measured, its superposition collapses to one of the possible classical states 0, 1, with the probability determined by the amplitude of the quantum state. This principle underscores a key difference in quantum computing. It measures a qubit changes the state of system, which can impact the final result and requires careful planning in algorithm design. Actually, this is basically a principle which has been uh, developed to determine, so that like now, if one input is coming, then where the thing is going to collapse, it will determine automatically. So this is something which is a research area which is still going on. A lot of things have been developed, and a lot of things have been going to be developed in it. Now see other principles of quantum computing. So now the first principle is no cloning theorem. The no cloning theorem states that it is impossible to create an identical copy of arbitrary unknown quantum state. That this is due to the nature of superpositions and interdetachment, which I have discussed before. That this principle has implications for quantum communications and quantum cryptography, where it helps secure informations as quantum states cannot be copied without altering them. It means, you see, it with the help of this a high level of security can be provided in these computers. Actually, but how this security is provided means, it will provide a complete encryption technology, so that one state cannot be copied in any case. If one state cannot be copied, that means it cannot be it means it provides a high level of security here. Then the next principle is quantum tunneling and tunneling relevant to quantum annealing. So let's discuss what it is. Quantum tunneling refers to the ability of particles to move through potential barriers even when they lack the energy to do so classically. This principle is used in quantum annealing, where quantum systems explore possible solutions by tunneling through energy barriers in the search space, which can potentially solve optimization problems faster than classical methods. Actually, tunneling is basically like what happens in tunnels. It can uh, one can move from one place in spite of any kind of problems, any kind of hurdles. The same concept is there. If information is going to flow in the system, it can it provides a way that in spite of any kind of hurdles, in spite of any kind of problems, it will move further. It will not stop. It will move further. So this thing, if we are providing this kind of tunneling system in the quantum computers, obviously it will provide better outcomes, better results in a less time. Then the next principle is quantum gate operations and reversibility. As I have discussed in comparison also, quantum computing use quantum gates to perform operations on qubits, similar to the logical gates in classical computing. However, quantum gates are reversible transformations, meaning they can be reversed to reconstruct the original state. So, like the state from which they have started, uh, they can go back to their state automatically. So the key quantum states include single qubits like Pollux, Hadamard, and phase gates, and multiple qubits gates like CNOT and Topoi. These gates manipulate qubit states and are combined to create quantum circuits for computation. Actually, these are the gates names like Pollux and CNOT and Topoi. These are the gates which are being used in developing the quantum computers, and these with the help of these gates, the complete circuit of the computing world has been developed. Now the next and the last principle is quantum gate operations and reversibility. So this is basically in this principle in this principle, the quantum error correction techniques are essential for decoherence and other errors. These include using intelligent qubits to detect and correct errors without measuring and collapsing the qubit states directly. Means it automatically, with the help of time, in the time being, it will automatically check out whether there are some kind of errors or some kind of collapse are going on in the qubits. It will automatically, it will detect these collapsing things and are going to rectify the problem. So this is something which is very going to be a way, it which is something very unique thing, and which is going to be a very wonderful thing in the quantum computers. So in this video, I have discussed about the brief about the about the quantum computing. It's advantages, and the comparison between classical computings and qubits computing, and the principles of qubits computing. Hope you people have liked it, and please give your comments. How do you like this video, and what are the other points which you want to know about qubit computing? I'm going to give you, I will make another video on those points. So thank you very much for giving time and time and your valuable suggestions for me. So thank you very much again, and happy learning. Bye.